now. Good afternoon. Good afternoon, professors. Today we're going to present the topics of personal loan approval using the machine learning. It is our senior presentation by me, Thongrop Bojib, and my colleagues, Rash Chujan. So this is our team, and today we're going to cover six of the topics, starting with the introduction on what inspires us and motivate us to pursue this project. Secondly, we will discuss in terms of the solution, approach to the project, and the setup for this analysis. And then the fourth one, we'll be talking about the results, discussing in terms of the business value. And next up, we will mention any of the challenge we encountered during this project. And the last part of the section would be any suggestion for the further improvement. So starting off with the situation analysis. I would like to describe the current loan approval process in the perspective of the loan applicants, which we assume to name Jake. When Jake tries to apply for the loan, he went to the loan officers with any of the information needed. The loan officers are responsible for the decision whether to approve the loan or not. So in case that his loan got approved, he has to make the payment period to pay the annuity every month, or else the loan become default. So the traditional credit scoring that the loan officer used to analyze, including the loan payment history, the current debt that Jake has, the credit history of him, and then lastly will be any other public records. And in this situation, Jake has waited for a week to get his loan approved, but suddenly he has a hard time to pay on every month, and then his loan become default. So we decided to summarize the current problem of the loan approval process. The traditional one is the very left. The loan officers, they utilize the credit history as well as the public records. But the pain point that we observe is that there are a lot of human errors coming in, and then that would result in bad debt rate. So the next solution that are currently in the market right now is to use the machine learning to approve the loan. So the machine will utilize the credit history, but they will leverage any of the third-party data, including the social media, so that they would make sense and understand the loan applicants more. But this still pose any of the problem, including the privacy issues, the underserved customer due to that the lack of the data. For example, the third-party data might not cover every single applicant. So this paved the way for our project to use the machine learning, but with the alternative data that we seek instead of the third-party data.
So in our engineering approach, first we got the data available in Kaggle to gain insights and understanding of the loan approval process. Through data exploration, we analyzed the characteristics of our dataset, uncovering patterns, trends, and potential challenges. This phase allows us to identify key variables, assess data quality, and lay the foundation for the later step in the approach. And with a clear understanding of our data, we move on to data pre-processing, a critical step to ensure the data quality of our dataset. Here we address issues such as missing values, outliers, and data inconsistencies to create a solid foundation for building the models. Next, we went on feature engineering to transform raw data into meaningful and informative features that capture the underlying patterns and relationships in our dataset. And with our dataset prepared and feature engineered, we proceed to model training, where we use machine learning algorithm to build predictive model that can accurately forecast loan approval outcomes. Finally, we arrive at the model evaluation, where we assess the performance of our predictive model, and we go back, use the result, and adjust the feature and iterate it to get the best performance. Next, we talk about the details. Here's the data model of the project containing many files provided by Home Credit. The first one is the application train and test. This section is the core dataset for this project. It contains various information about the applicants, for example, age, gender, amount of credit, amount of income, etc. The bureau files contain the data from previous loans that the client got from the other institutes that were reported to credit bureau. And next is previous application, which contains the client's previous loan in home credit. And POS cash balance contains the monthly balance of client's previous loan in home credit. And installment payments contains past payment data for each installments of previous credits in home credit. And lastly, the credit card balance contains the monthly data of client's previous credit card loan in home credit. So what we did in data preprocessing include the data cleaning, detecting anomalies, and handle missing values. For example, there's one features about the days employed that has 300,000 days, which is apparently incorrect due to the human error or other things. So we get rid of that. And later in feature engineering, we did data aggregation, feature extraction based on feature importance and one-hot encoding, for example, annuity to income ratio and age range, etc. For the model training, we split train validation and trace and use the light GBM to train the data. And on the model evaluation, we use the K4 cross validation to estimate the model generalization performance, conversion metrics, precision recall, F1 score, and AUC, ROC to evaluate the overall model performance, and feature importance to reiterate the process and see which features are more significant. Next is our experimental setup. And this is how we set up the experiment. First, we train the data with a control model which doesn't have alternative features. And the second one is model trained with a base feature plus alternative features. For example, occupation information, educational background, and housing type.
Okay, now as my colleagues mentioned about the experimental setup, we can see the result benchmarking between two models. The main difference on the feature includes is that the model with alternative features has the selected columns, which includes the occupation type, education type, and the housing type. So the insights that we can see here is that we have a little decline in AUC scores due to the trade-off between precision and recall. We can see that the recall has gained a significant boost of 10 times more, and the F1 scores are particularly low, but still got an increase. So what are key insights that we see here? Firstly, is the increase in recall with the precision. As we aim to utilize the ML to minimize the non-performing loan the most, the increase in recall favorable to us. But however, we have to discuss about the low F1 score interpretation. So according to the current data set in the industry, the loan data set is skewed towards the non-performing loans. So that F1 score with very low are seen across of the competition. And the competition are focused on AUC scores. So we can further visualize more on the categorization of this model by looking at the confusion metrics. We can see that the model performing very well in terms of detecting any of the non-default loans, which are most of the data sets. So in the data sets of about 300,000, we have just only 10% of the people who are non-performing loans. So we can see that we detect half of it, which means that we detect 12,000 more applicants than the controlled models. So furthermore, we're going to answer the research question that these alternative features would gain more understanding of the applicant profiles so that for the limited financial history applicants, we can still maintain the performance. So we're going to address the challenges that we encountered. Firstly is that we see the decline in the overall AUC score. That's because of the trade-off between the sensitivity and the specificity. So there needs to be any of the further optimization so that we can maintain the AUC scores and the precision while gain the significant boost in recall. Secondly, in terms of the single data source, so we are dependent on just the resource from the home credit score. The dataset is from the real world, however, it's just from one financial institution. So this might cause the overfitting to the loan applicant type. And furthermore, investigation and integrate any more of the data source is required. The third challenge we encounter is the imbalance in dataset. As we can see that in the nature of the business, of course, that the non-default loans are more present, and just only about 10% are the default loans. So the data set is pretty skewed, so that limits the model understanding of the default loans, resulting in low performance detection just for the default loans. So what are the solutions here? To handle any of the challenge we mentioned, firstly is that I would suggest to do more of the data acquisition. So unlike the model that utilize the third-party data, acquisition here means that we have to find more of the loan payment history and any of the default loans from any other source like financial institutions so that we gain more understanding about the default loan behavior. And then secondly, we could apply any of the more advanced model techniques. For example, the resampling methods, which we have implemented, but we have not seen any of the improvement in terms of the result. But I would suggest that any of the feature engineering, feature selection, and the techniques would be able to help with the maintain of the discrimination power. So further application that I would like to suggest for the research is that we can explore more of the alternative features like any of the psychometrics evaluation from the loan applicants, and then we could classify whether or not that would help us understand more about um, the default loans. The second future applicant is that we could deploy this model, but to not to replace any of the current method, but to test alongside the existing models and to benchmark, compare the performance against it. So this would help in terms of gaining more understanding of the data sets for our model. Lastly, we came to the conclusion of our presentation. Our project implements the algorithm of the machine learning with the existing features of the home credit datasets so that we aim to become less dependent on any of the third-party data and become more financial inclusivity so that we reduce any of the underserved bank customers. So with the result coming in that we gain the boost in recall, but we still need any more of the improvement as well as the data acquisition. Further improvement is needed so that this project can be the fundamental for any further exploration in loan approval model. So this would be all for our presentation. And next, we're going to answer any of the question. Thank you.
Okay ครับ Professor please ask and comment
ค่ะอาจารย์สุกรี could you please comment first ขอบคุณค่ะ
ครับ why like GPM? What is the motivation behind that?
Okay, so I think that my colleagues would be able to answer that. But first of all, we have explored a lot of the models type, including XGBoost, regressor, any of the one that would help in the classification problem.
So the light GBM can handle like there's like many missing values and data that the other models does not handle very well, and light GBM can like train for faster speed comparing to other boosting algorithm like XT boosting. So with a very large data set, we decided to use the light GBM for this project.
Okay, so I'm sorry that I would like to know the number of data I get.
Around three 300,000 rows, and the features around 300 features columns.
Okay.
So may I ask one? I think you also mentioned about the feature importance. So what are the important features finally?
I think we have the feature selection that they are being rated if we use the random forest. So we did use the random forest once to visualize which are the feature importance. Like I think the words is a gain that helps the model gain more understanding. It comes up that of course the traditional feature like the pass credit scoring and the ratio of the annuity to the income basically represent whether or not they will be able to pay this amount of money in monthly. So these perform very well. And another features that are really important that they give us is the external source. The external source is like they send the loan applicants to do the testing for the online, and then they will receive the score. So these are one of the columns that really uh, give our model more understandings. But in terms of our alternative features, right, we can see that the occupational information are really relatable to how the loan being classified. As for the occupation, it will comes in like the job name first, and then we categorize it based on the distribution. So we visualize any of the job on how contribution to the target, and then we separate it into 3 groups. The groups that are highly related to the target being one. These are the low income type of group. They are most likely the labor workers and then the cleaning staffs, so that we label it as the low income type. And then we do this for 3 more of the groups. So I would say that based on the alternative features, the occupation information contributes to our model the most, being the most important, right?
Would you please show me the result again?
Ừ.
The result tab.
Yeah.
Ừ.
This is the class of the default one or not default
Right.
one.
Tab.
The
It's for
result of
the default one, tab.
the default one. What is the distribution of the default one?
The distribution.
Yeah.
Could you
How many of
clarify?
them?
Oh, okay. It's the here ครับอาจารย์uh 1100 add with the 13, so basically 24,000 24K
24K with comparing to the non-default.
ครับ so it's like
Okay.
Less
24
than
to
10%.
280, about
Okay, so
9%.
Okay, it's about 9%, right?
ครับ
Right.
9% of the default one. You can gain the recall to 54, and the precision is lower. The precision that is much lower. Okay. This one is the alternative feature, right? Do you have the confusion matrix of the controlled model?
of course ครับอาจารย์ Ras we have it right
Yeah. Would you please compare it? I would like to know the actual number. Because the precision is much lower.
I don't think I have it, but let me see. The first one that I remember, it's like it most likely is guessing mostly the non-default. So
So the problem is I am trying to check that which number is much lower, because the precision decreased from 57. The precision of the default one, the default is 0, right? No, the default is 1, right?
ครับ the default is 1
The default is 1. So in this case, yep, it is 24%. Yeah, from the so actually you should compare using the raw data also, because we have to know the actual number. For example, this is 24, right? So maybe because the recall is much higher, it's 50%. So this the number of the bottom row, in the control model, I think it should be around 25. It should be around 5%. Is the original maybe 7,000, I think, in the bottom right cell. And I'm trying to find the number that is changed. So I think you should analyze that, because the recall and precision is radical change. Yeah, this one. Yeah, this one is original one, right?
correct ครับ
Yeah, so it means that it always predicts as the non-default one, and you move when you use the new one, it can predict more default case, right? Around 10,000, move from 23,000 to 1,400. And in the top row around 1,000 also, right? Can you show the new one comparing?
Show it side by side.
Yes, show side by side, please.
โอเคครับอาจารย์ I will multiply the slides real quick ครับอาจารย์ so this is the old one please take a look for a while ครับ
Okay, so it means that one around 10,000, right? Around 10,000 move from, you can predict correctly 10,000 actual default case, but it's wrong also around 10,000 also, right? I'm not sure. Please, can you show it side by side like Ajahn Vishnu said?
ครับ in this moment ครับ just a second ครับอาจารย์ โอเคครับ I'll share the screen now ครับ
โอเคครับ
อันนี้เห็นไหมครับ
โอ
Can
เค
you
ค
see
รั
it
บ
so the left one
อ๋อ
is the old one ครับ
Yep ค
the
รับ
control and then the
อือหือ
right one are the one with additional features ครับ
So it's like it's this is like the normal situation that when you want to classify it to be the default, when you need more examples to be classified as the default one, the top row, can you see? The number of examples that is like around 40,000 examples incorrectly classified. Can you see?
ครับ
So this one because this is imbalanced data, but I'm not sure that did you use any techniques that can help in the case of imbalanced data?
like resampling
I use undersampling,
Undersampling.
oversampling, and I tried undersampling, oversampling, and like hybrid of like both. It's the F1 score is still pretty much the same. There's like a little bit like trade-off of like recall and precision, but the result the overall F1 doesn't change that much. I also tried threshold adjustment, which got like a pretty similar F1 score, but like very close recall and precision.
But in this case, you have to think about because this is like the financial company, right? Or maybe the bank. So it means that the number of cases that is incorrectly classified from the non-default to the in the top right corner. In the top right corner, the actual non-default will be classified as default one, right? 40,000 cases around that.
right
Of non-default will be classified as the default, right?
right ครับ
So in this case, it means that you lost around 40,000 customers that actually you should grant the loan, but you didn't, right?
Right, but assuming that you get only like 5 to 10 interest from the customer that you decided to give the loan, but instead if you receive a bad debt of about 12,000 customer, that would lost all of your money.
Yeah. So
ครับ
you should add this to your report. Okay. That because I think the serious error is the lower in the bottom left corner, right?
Bottom left, the one that we let the default loan become default, right?
Yes.
Yep.
Yes. Actual one, but it predict as 0.
Right. Yep.
Yeah. So you in your report you have to compare this error. That is, you can reduce it by like almost, I think 12,000, right? Around that.
Yep. 12,000.
12,000. And the other error that happened in this case is 40,000, right? Top
Yep.
right corner. But in the financial aspect, this one is highly improved, right?
Yep. Yep.
Mhm. So you should report this in your report or in like data analysis or discussion part.
โอเคครับอาจารย์
Okay. Did you report other techniques comparing to yours or use only the light BGM?
We only use the light GBM ครับ
in the report, right? But we have tried and evaluates the XG
Yep.
boost as well.
Yep. So actually you have to compare it.
ครับ so the
Mhm.
control models and the alternative for light GBM for XG boost
Yes.
and so on ครับ
Yes.
Yeah.
I think around you should use like, okay, random forest, XGBoost, and light GPM,
ครับ
and use XGBoost or random forest to be the benchmark model, and try to show that your data can be your method, your presented method is like much better. One thing that I would like to know is how can you divide the training and test data?
Oh, okay. So in this competition ครับอาจารย์ so it will give us the
Dedicated
application
test
string,
set, right?
right? And the test will not have any of the target.
Okay. But finally we know, right?
ครับ
The result reported in your presentation comes from the test set, right?
ครับ
Okay ครับ so you have to you have to present or try another model because you
ครับ
claim that your method is better than that, right?
ครับ
So
And
you have to present random forest and XGBoost result,
ครับ
but
Yes,
just only in one table. That's fine.
ครับ okay ครับ and state that we decided to select light GVM, right ครับ
Mm-hmm.
โอเคครับอาจารย์
Mm.
and visualize or discuss the data in terms of financial impact as well, right ครับ
Yes ครับ Okay ครับ I have no other questions ครับ Thank you very much.
Actually, I think most of my questions already asked by Ajahn Sukri. Okay, and I think, right, as Ajahn mentioned, right, do the comparison among the techniques. Okay, and also do the discussion about the result as you have shown right now, right? The gap analysis, something like that, and also the error analysis, right? And also, when Ajahn asked about the split or data splitting, do you also do the stratify, right?
Yes ครั
certified
บ
ครับ
And I think you have quite a lot of features, hundreds, about 300. But then I think when I asked about the features that are important, you show only 3. Is that correct? I mean, one slide.
Russ,
Uh,
can we pull out the feature importance?
oh,
We have
right.
the
Wait,
document.
wait a minute.
Or what are the techniques that you use to do some a step of the feature selection, or just use all of them and then you just
Oh,
interpolate or something like that
ครับ
according to their importance?
So ครับ to answer your question ครับ so there are some of the features that a lot of the features has been modified into variants of like min, max, mean, and then STD, and then we got all of the variants of it. So we use feature importance to see, hey, if in this particular feature, which type of variants are most suitable for our project. ครับ And then a lot of the features has been engineered like doing the ratio, or we do the multiplicatives on the existing one that I think we are relevant. So would you mind if we show the collab code so that you could see any of the features we decided to engineer?
Right, and what are the features, I mean, final list of the features that you use
Final.
to train your model, right? But you
ครับ
can also show how can you engineer or do feature selection.
ครับ of course ครับ Okay, so I have received a picture the document sub feature importance now, and I will share it with you ครับ can you see the screen ครับอาจารย์
ค่ะ in the Excel, okay.
ครับ Oh, sorry. Okay, Kap, here. As we mentioned that the external source are like it comes with the 3 types of external source. So basically it means the applicant has filled in any of the tests from 3 different website. So we have found that the variants that are best suitable for us is the mean for the external source, and it contributes the most gain and splits the most gain. And here's the organization type, or what kind of uh work they work for, the company type ครับ and then there are other variants of the external source as well, the minimum, and then the credit to annuity ratio, meaning that what are the price of the object you decided to apply for loan is the amount of credit, and compare that with the amount of annuity or how much you have to pay per month. So by dividing this in terms of the ratio, we can see or imply that how many months you have to pay. So number of months you have to pay for the loan to end contribute largely to the gain. And then other type of the external source variants have, so the third one, the max, and then occupation type, as we mentioned. So are you working in a low income class, the middle income, or the high income, like an accountant? ครับ
ค่ะ
And then
so
other types of ครับ
okay, so the list here will be all the features at the beginning, or you just use the top ones to train the model?
ครับ so uh we decided that we just
Right,
use
this will be
only the
300
threshold.
something, right?
ครับ we use just threshold of the gains ครับ so basically we have about 600 of them, but we decided to use just 300 by adjusting the threshold, so not any of the gains below 3,000 ครับ
อืม ค่ะ แต่ว่าอย่างline 361 wall smart อะไรเนี่ย wall material mode
ครับ
it's not what is it? This one is still in range มันเท่าไหร่
in
นะคะ in house, right? The last line for the house, the
ค
value
รับ
will be 3,000 something, right? So this
ค
is
รับ
the cut off.
ครับ so we
Mm.
did we make the threshold. So any other 300 features below that we don't use have.
Mm-hmm. And what are the representation of each value? For example, for the house.
The representation you mean like example of data point, right ครับอาจารย์
Right.
we can look at that in data dictionary ครับ
ค่ะ
Just a second,
this
ครับ
true.
So house.
Mm.
House is a type of housing applicant ครับ So
Okay.
it is hard coded into 0, 1, 2, 3 ครับ So ครับอาจารย์
Okay, but you don't use the ID, right?
the ID no ครับ not the ID ครับ
ค่ะค่ะ Okay.
ครับ thank you ครับ
But then later in your slide you show only three, right? The top three that have most effect for I mean your model, the annuity, annual income, something like that in the slide.
ครับผม
Mm-hmm.
So the three things that we decided to include are the one that we do further feature engineer or decided to do the grouping based on the distribution ครับ So these three we have to map what type of education or what type of occupation by the thing that which visualize on what groups tends to relate to target the most, something like that ครับ. And these are pretty like alternative compared to the traditional one, like the external source or credit to ratio, something like that ครับ.
ค่ะ but you didn't train the model using only three features on the left, right? You still use 300 something.
ครับ But the
Mm-hmm.
300s are classified as just the normal one, like we got from the merged data. So you can see the merged data only got data about financial history and the bureau, the payment period, the credit cards ครับ
Mm-hmm. Okay ค่ะ Mm-hmm. ค่ะ and you did undersampling, oversampling, something like that, but you still get not that good result, right? Mm.
ครับ
Yes ครับ
ค่ะ Did you add those results in your report? I mean about the handling of the imbalanced data set?
You mean like if we should compare the before and
Mm-hmm.
after usage of imbalance?
Right.
โอเคค
ค่ะ
รับ
At least we know that you try, I mean, several things. I mean, not only mention that you can improve. Okay.
ได้ครับอาจารย์
ค่ะ อืมอาจารย์คะ อาจารย์สุกรีคะเออ
ครับผม
เออพี่ยังสงสัยว่า it should get the better result, right?
น่า
ดูแล้วมันไม่รู้ว่าทำไมมันดูผลน่ะ not that good เออค่ะ
มันน่าจะยากครับพี่ Data มันยาก
เหรออ๋อ
ครับ
โอเค
Data มันยากคืออย่างน้อยมันต้อง แต่เราจะรู้ว่าดีขึ้นหรือไม่ดีมันต้องเปรียบเทียบกับของอันอื่นๆนิดนึงอะไรเงี้ยถึงจะรู้ครับ
ค่ะ อืมโอเคค่ะ so I don't have any more questions ขอบคุณค่ะ
to sum up, you guys will have to do display the result in the report, the result for other models in the report, and compare them with your models more, right? Like Ajahn Sukri suggested, and also with the oversampling and things that you have done in order to deal with imbalanced data. You have to write down what you have done and the result as well before and after what you've done.
ครับ
Okay.
And also the discussion of this error analysis that อาจารย์สุกรี mentioned at the beginning, right?
ครับ
Okay. Okay. So I guess we're done. Any other things, Professor?
no ครับ
โอ้ไม่มีแล้วค่ะ
โอเคครับถ้างั้นก็
ขอบคุณ
ขอบคุณ
ครับ
มากครับ ขอบคุณมากครับ
ไป
เดี๋ยวจะ
ให้
ให้ไปปรับ
เกร
ปรุ
ด
ง
ใน Moodle นะครับ
ได้ครับ เดี๋ยวให้ไปปรับ
โอเค
ปรุง
ครับ
รายงานครับ
ขอบคุณครับ สวัสดีค
เว
รั
ลา
บ
ฟีเจอร์
ค่ะ
ฟีเจอร์มันเยอะไป มันเลย
ค่ะ
ได้หน่วย
ส่วน
ยาก
ตัวพี่
เจอที่เลื
ก็
อก
คิ
อะ
ดว่าอย่าง
เย
นั้น
อะ
เหมือนกัน ค่ะ โอเคค่ะ
โอเค
ค
ค
รั
รับ
บ สวัสดีครั
สวัสดี
บ
ค่ะ
ขอบคุณครับ
สวัสดีค่ะ
สวัสดีครับ
อือฮึ
โอเค นะเรียบร้อย ก็
ครับ
เดี๋ยว